Subtopic for today is potential difference. In the earlier chapters, you have learned about potential energy that is due to the position in a field, for example, gravitational field or electric field or magnetic field. Okay, so that's basically when you have the particles or the mass move to a different position in the field, then it will gain the potential energy. So potential difference, what's the idea here? Let's look at this picture where we are talking about gravitational potential energy. If we take the ground as zero potential, and then somewhere higher there on the table there's a non-zero potential value. So this value, if you minus with the zero there, let's say we have 10 as the potential at the surface of the table, then we minus with the 0, so 10 minus 0, that's actually the potential difference between these two levels. So potential is like a value that you give to the two different levels in the field. Then if you have the mass, which is this water here, if the mass is moved from a position or a level of 10 to 0, then we say that there's a change in the gravitational potential energy. So the same thing apply into an electrical circuit where charges is like the mass in the gravitational field there. So this charge, if you move to a different level or a different position in the electrical circuit, then as it moves from one point to another, it will have a change in the electrical potential energy. So between the 2 points, just like between the two levels in the gravitational field, so between the 2 points in an electrical circuit, let's say the point A and point B across a lamp, so there is a different potential that we call the potential difference. So from here to here, there is a potential difference, and if charges move across that, then it will have a change in its electrical potential energy. So what happened to this electrical potential energy as it moves across the electrical component like the lamp here is that it will be dissipated through the light and heat. Okay, so there will be light and heat energy dissipated. That is, it is converting the electrical potential energy into light and heat, and therefore potential difference can be defined as the electrical energy converted into other forms of energy per unit charge at the component. Okay, so it's per unit charge. So what is mean by per unit charge here? That is, for each unit of the charge, that will be the equivalent, that will be the electrical energy converted. So let's say you have 1 volt as the potential difference, that will be equivalent to 1 joule of energy divided by 1 coulomb of charge. So that's the unit charge there. Okay, and therefore the equation is V equals to W over Q. So V stand for the potential difference, W stand for the energy, amount of energy involved or converted, and divide by charge, that's per unit charge. Okay, and the unit is joule per coulomb, or V. So come back to this W in the equation here. It can also represent for work done. Okay, imagine if we have two metal plate, one is positively charged and the other side is negatively charged. Okay, and there's an electron there that we want to move it to the other side. We want to move from the negative plate to the positive side, and we know that it's from positive side to negative side, and we know that because electron is negative charge, if we want to move to the negative side, there's a repulsion. Okay, so there's a repulsion by the negative side, repulsive force. Okay, repulsion. So if you want to move this electron towards there, you need to do some work on it. Okay, you need to pull it there. The force need to attach or pull the electron all the way towards the negative plate. So if you successfully do that and the electron arrive at the negative plate, now it will have converted your work done into in its electrical potential energy. So it has some energy that's called the electrical potential energy. That's also equivalent to the work that you have done on it. Let's say you use 5 joule to move it, then you will have gained 5 joule. So what happened is that it can recover this energy. It can use this 5 joule to do work. So what's the, for example, work that it can do is like because once you release it, it will move back to the positive plate. Okay, it can move to the positive plate because it has that energy. It will make use of that 5 joule of energy to go back to the positive plate. Okay, so you can see that these concepts are all interrelated. The work done and the electrical potential energy, and when the charges move through electrical components inside an electrical circuit. So remember just now I say that 1 volt is when you have 1 joule of energy converted per unit coulomb. So that's basically the text is trying to mention. 1 volt is PD across the component when 1 joule of electrical energy is changed into other form when 1 coulomb of charge is moved between the 2 points in the circuit. Okay, so it means that volt itself, you can define it as joule times coulomb. Alright, so that's all for potential difference and its unit volt. I'll see you in the next video.